Welcome back, guys, and we are here for our last section of Chapter 2, 2.7. And we've been solving equations the entire chapter, but we're going to take a bit of a left turn here and go to a different topic. We're going to jump into what probably is review for you, measures of central tendency. What are measures of central tendency? These guys, mean, median, and mode. We're also going to talk about spread of the data. So usually I start by instructing you all, but I actually want you to practice this first. Give it a whirl. I want you to go ahead, pause the video, and see if you can match the three. Okay, now that you have done that, let me get my pencil, your smartboard pen. Let's see how you did. The mean will be the sum of the data divided by the number of data items. The sum of the data divided by the number of data items. If 5 of you take a test and I want to find the mean, I'm going to add up all your test scores and divide by 5 because that's how many of you took the test. Next, median. Median is the middle value. Median. I usually remember it by the letter D in the middle because the letter D is in the word middle and median. It's the middle value when data is ordered smallest to largest. Again, with those 5 tests, how would I find the median? Well, I order them from least to greatest, and I just pick the middle value. And then finally, mode. Mode is the item that appears most often. Again, a little mnemonic, or not a mnemonic, but a little way to remember that. Mode and most. If 3 of you got the same test score and 2 of you got different ones, the mode would be that test score that all 3 of you got. Okay, pretty simple, and this might be review. But the new part is going to be this. Again, we're going to ask, when do we use what? Sorry about that. When do we use what? And this one I want you to try and figure out, but it's a little trickier. So pause this and try and match them up. Unpause it. All right, so we're back. You've paused it, you've tried. You probably started out and went, well, mode, most popular. Okay? Non-numeric or choosing the most popular. Again, this is what the mean and median and mode are good for. When do we use what? Choosing the most popular. If I'm looking at the color of shirt all of you are wearing, the most popular one, I'm going to go ahead and use the mode, okay? Good for non-numeric data. Color would be a great example of that. Now let's get to these two, mean and median. Often called the average, but it's good when there are no outliers. The other one is good when there are outliers. You might have had to think about this for a bit. Okay, so let me give you an example here. Let's say I have the following test scores for you all. 27, 85, 86, 90, 91. Okay, I'm going to do some quick calculations here. Again, we know mean is adding them all up, dividing by how many there are. So 25 plus 85, or 27 plus 85 plus 86 plus 90 plus 91 gives me a grand total of 379 divided by the 5 test scores. And your mean here would be 75.8. The median, on the other hand, is where we cross off, and our median would be 86. Okay, I'll delete these lines. Median would be 86. Now, if you look at those, which is the best measure of central tendency, or which most accurately describes the data? What I hope you're telling me is the answer is median. Now, why would median be the best here? Because what I hope you recognize is the difference between these two options is one's good with outliers and one is bad. What I hope you just saw from my illustration is that 27 is an outlier, and it significantly impacted the mean, whereas it had very little impact upon the median. Why? Because the outlier immediately is crossed out. An outlier will always be at the end of the spectrum, so median gets rid of it, whereas mean is significantly impacted by it. So when all is said and done, how do we choose what goes where? Well, via that little illustration, you can try it on your own if you want to do further study. Mode obviously is non-numeric most popular. Your median is going to be excellent for outliers, and your mean will often be referred to as the average and is good when there are no outliers. Again, why do I say average? When I say your average test score for your class, it means I calculated the mean, not the median or the mode. But the big thing I want you walking away with, what is good for outliers? Please think median. Again, an outlier will be on the end of the spectrum, whether it's large or small, and we will simply cross it out with median, but it will significantly impact the mean. Okay, so median is very good for outliers. So here's an example. We're going to find the mean, median, and mode of the data below. And we're going to just figure out which measure of central tendency best describes the data. So this is hours that employees worked at a local restaurant. Okay? Hourly wages of employees at a local restaurant. So you can see here, at our restaurant, we've got 8 employees. We've got 5 brand new employees, 8. Why did I say 8? We've got 10 employees here. We've got 5 brand new employees just started this summer. They're making $6.25 an hour. Please, I know this is below the current minimum wage, but it would be an example from like 10, 20 years ago. 5 employees just started, they're making $6.25 an hour. 3 employees, who this is their second summer working there, are making $6.50. We've got a we'll call it assistant manager at $7 an hour, and then the manager is making $8.25. Again, we want to find the 3 measures of central tendency: mean, median, and mode, and we want to figure out which one best describes the data. The easiest one to find, as you've probably figured out, actually go ahead, pause the video, and find mean, median, and mode on your own and check your work with mine. Also, once you do, figure out which one best represents most of the salaries. Okay, so now that you've done that, the easiest one to find is mode. Mode most often. Well, it's very clear that most of our employees are making $6.25 an hour. Now let's go ahead and find the mean. The mean, as we should discover, the mean will come out if we add up all of our data and divide it by how many options we have. So I'm going to add up 5 625s, 3 650s, 1 7, and 1 825. Then I'm going to divide that by 10, and I get a mean of 6.6, or $6.60. And then finally, I have my median. And my median, I'm going to work my way from each end, okay? So I'm going to slowly cross off each one, end to end. Okay, so what happens if you think back to 4th grade when we have an even number and I've got 2 in the median? Well, what I'm going to do with my 2 choices here is I'm going to add them up and divide by 2. So at 625 and 650, we're tied for the median. So I add them together and divide by 2. When I do that, I end up with 6.375 is my median. So I end up with all that work. Again, if you're confused on how to find mean, median, and mode, please feel free to come talk to me at some point. I can help you out. Sorry about that. $6.375. So the question becomes, which best represents our data? Now, I hope if you paid attention to the first part, you already were thinking in your brain, probably going to go with median. Why? Because it's numeric data and there is an outlier. Outlier. Again, if you don't know what an outlier is, come talk to me. It's a piece of data that is way on the outside. There's an outlier. So hopefully our brain was going ding, ding, ding. Mean probably won't work. But let's look at this. The mode was 625. So why would the mode not be a good example? Well, let's think of it. Why is the mode a bad example? Well, the mode is not a good measure of average salary because it's equal to the lowest 5 salaries. That's not a great example. If you went to a company and said, what's the average salary? And they gave you the lowest, 50%, that's probably not a good marker. The mean, on the other hand, so the mode fell here on our timeline. The mean fell here. The mean has the opposite problem. It is larger than 8 out of our 10 salaries. So the mode was equal to our lowest 5 salaries. The mean was larger than 8 of our salaries. The median, on the other hand, falls right smack in between. Okay? And that is what we want from a measure of central tendency. We want it to be right in the middle of all our data. Median, therefore, is the best option. Again, if this example is confusing to you, if it's not making sense, please pause and email me. So this is how we use, in practical situations, mean, median, and mode. Certain measures of central tendency are better than others given certain circumstances. Median, in this case, is the best. Median will always be the best with outliers. Mean, on the other hand, is great when we don't have outliers. In mode, when we have non-numeric data. So what's another type of practical problem we could see where the mean is used? Well, pretend you're me, and we can figure this out. So you're going to see a lot of college kids actually do this come exam time. So let's say you want a 90 average in the class. You want a 90 average that's right on the cusp of an A. And you got an 83, 90, and 91 on your first 3 exams. What do you need to get on your 4th exam to get that 90 average? This is a very practical problem. Again, a lot of college kids do this. You might even do this toward the end of your semester this year to figure out what you need to get in a class. So we want a 90 average. Our goal is a 90. Again, another word for average, especially with test scores and no outliers, is mean, okay? So we need to be thinking here about mean, and what's the formula for mean? Well, mean is when we sum all of our data, and divide by how many pieces of data we have. Okay? Keep this formula in mind because that's how we're going to set up our problem. We want a 90 average, we achieve an 83, 90, and 91, and we want to know what we need to get on our 4th exam. So we actually, combining 2.6 and 2.7 here, we actually already know the mean. We want a 90 average. So if I'm going to set this problem up, I know I want a 90. That's my goal. Well, what's the formula for mean? Well, to find the mean of my 4 test scores, I'm going to add all of them up and divide by however many there are. There are 4 exams. So 4 will be on the bottom. My first exam, I got an 83. My second, I got a 90. My third, I got a 91. And I don't know my 4th, so I will put a variable there. Again, this is how we're going to figure out how to find the 4th exam. We use our equation for mean, plug in the data where we know it belongs, and then solve for the variable. Okay, so we're trying to find x. Well, what can I do here? I'm going to first combine like terms. I've got a bunch of constants in that numerator. So 83 plus 90 plus 91 gives me 264. plus our variable divided by 4 equals 90. From here, it's just an equation you all already know how to solve. Everything's being divided by 4, so I will start by multiplying it by 4. When I do this, I get 360 equals 264 plus x. Subtract by 264 from both sides, and I'm going to get x equals 96. X equals 96, okay? Which means in the context of the problem, I must get a 96% on my fourth exam to get a 90 average in the class. So then, if they ask me the question, could I get a 92 average? Your resounding answer would be no. Oh, I'm sorry. Could you get a 92 average with getting a 96? The answer is no. The general question, could you get a 92 average? Sorry, I read that wrong. You do the same process. Instead of a 90, we're going to solve for 92. Again, set up the same exact problem. Can I get a 92 average? Okay, we found out what we needed to get on our final exam to get a 90 average. Now we're going to figure out if we are capable of getting a 92. So again, I set up my formula, run through some similar math. Four times 92 will give me 368. And again, that comes from multiplying both sides by 4. Okay, so I subtract 264 from both sides. And I find out x equals 104. So is it possible for me to get a 92 on the exam? Answer, can I get a 90% or an 104%? No. It's not possible, right? The highest score you can get on a test without bonus is 100%. So my answer would be no. It is not possible for you to get a 92 average on your exam or in the class because you can't get a high enough percentage on your last exam. So to summarize so far, we used our mean or our idea of mean to figure out the fourth test score we would need to get a 90 average. We then used the same setup to figure out what we would need to get a 92, but when we did that, we figured out we would need a 104. Because it's impossible to get a 104 without bonus, it is not possible to get a 92 average in the class. Again, if this was too quick for you or it did not make sense, please pause the video now and contact me. So the next part of our lesson, we're going to talk about range. And unlike mean, median, and mode, range focuses on the width or the spread of the data. Now, why is this important? Well, I'll show you. So find the mean in the range of the following data. Mean, remember, you add them all up, divide by however many they are. And range, what you're going to do, if you don't remember range, that's the distance between the largest piece of data and the smallest piece of data. So look at these examples, find the range and the mean for both. Okay, now that you've paused it and done that, let's go ahead and find the range and the mean for both. Or let's check your work. Well, I want to find the range and the mean. Well, mean says add them all up, divide by however many there are. There are 5 in each case. So the mean for the first one would be 25 plus 30 plus 30 plus 47 plus 28 divided by 5. And I get a mean of 32. Second one, 34 plus 28 plus 31 plus 36 plus 31. Divide by 5, and again, I get 32. So the mean is the same for both. Let's check the range. Well, my largest piece of data is 47, and my smallest piece of data is 25. When I do 47 minus 25, I get 22. On the other hand, down here, my largest piece of data is 36, and my smallest one is 28. 36 minus 28 gives me 8. What I hope you notice here is not only are we going to care about data and what the average is, but we also care about the spread of the data or how widely dispersed this is. Think if this were test scores out of 50, right? On the bottom here, we've got pretty much everyone kind of in the middle of the road. They messed some up, they got some right, but you all are tightly packed together. There's a much bigger spread in the top one, though. Some kid aced it and only missed 3 points. Someone else, on the other hand, got a 50%. And there's a much wider spread of data. You see, not only do we care about the average of data, but if data is very consistent or packed together like the bottom, or is it inconsistent, non-consistent? Is it much more widespread? And range is one of those measures that tells us that. So again, range is a statistical measure that, unlike mean, median, and mode, tells us the spread of the data. My final question that I would like you to think about is, do you think range is impacted by outliers? Do you think range is impacted by outliers? Think about it for a second. Okay, what I hope you came up with is a resounding yes. Okay? If this 47, yes, range is impacted by outliers. And why? Because if this 47, which we could call an outlier compared to the rest of our data here, is switched with a 35, the range will not be as big, right? 35 minus 28 is 7, whereas 35 minus 25 is 10, whereas 47 minus 25 is 22. Okay, it's a much bigger gap. So yes, range will be impacted by outliers. Okay, I hope most of this was review. If anything's not, let me know. I know some of the new parts might be solving equations with mean or thinking about how outliers impact stuff, but hopefully it makes sense, and congrats. You are officially done with chapter 2. Study up for your test and let me know how I can help.